So yesterday we talked about reading polynomial equations based on their graph. Today we're going to take a graph and write the equation. So as we look at this graph, we can clearly see that it is crossing at a -5. And we need to remember that this comes from the factor x plus 5. And we can see that it's also crossing at +8, which means it's crossing, it has a factor of x minus 8. So this is the equation that we come up with based on the x-intercepts. Well, the problem we have sometimes is we need to account for stretches and compressions on the graph. So I currently have this function as f of x equals x plus 5 times x minus 8. So if this function's correct, the y-intercept should match what we have here, which is 80. And remember, we get a y-intercept when x is equal to 0. So let's see if our equation works out. We plug in 0 for x here, and we plug in 0 for x here. So we end up looking like this. This ends up being 5 times -8. So the equation that I've created has a y-intercept of -40, which we can clearly see is not the y-intercept that we have at the top here. So all we have to do on this to regulate this is to create an a value that fixes it. We are supposed to have a y-intercept of 80. We have a y-intercept of -40. So what we do is we can just tack an a onto this. We could have done it at the beginning, or we can do it at the end. But we tack an a on this, and we can adjust our equation to where it is the correct amount. So I would divide by -40. And this gives me -2. So we have a leading coefficient here of x equal to -2. All we have to do to make our equation right, this equation is correct based on the x-axis, or the x-intercepts, but it is not correct based on the y-intercepts. So all we need to do here is to simply tack a -2 onto the front of our original equation. So what this equation would read is f of x equals -2 x plus 5 times x minus 8. This is a version of the answer. The other thing we can see is if we were to distribute these values together. This would be the FOIL method. X squared minus 8x plus 5x minus 40. And we need to remember that these values are in parentheses because there's a -2 in front. So this becomes x squared minus 3x because the 8 and the 5 are like terms. And after distributing a -2, we get the equation plus 80. -2x squared plus 6x plus 80. You already know what I'm going to tell you to do on this, which is to graph. If we have an answer and we're not so confident in the answer, all we need to do is make that answer, or graph that answer, and see if it shares the same table, or shares the same graph, as the graph that we're looking at. Now in this case, delta math is going to actually allow us to have either of the two answers. So we could have the answer that we had at the very beginning before distribution, or we can have this. Reason why I showed you the second way is because more than likely on your ACT, it's going to be written in this standard form. So as we take a look at this one, we see that we have a crossing at -4, which comes from the factor x plus 4. And we also have a crossing at, looks like +5 here, which comes from the factor x minus 5. Now, just like we recognized yesterday, at the 5 solution, we have a multiplicity happening because we have a weird behavior happening. In this case, it's the bounce, which indicates that we have an even multiplicity. And in this case, it is 2. So this is how we write the function, but just like on the last one, we could have a scale factor issue on this. According to our graph, we have a y-intercept of -90. So when we plug in 0 for x, our y value should come out to 90. If it does not, that's where we have to use that scale factor in the front in order to regulate it. Let's put an a value right there in front. If we need it, we'll see if we do. So on this side, we see 0 plus 4 is 4, of course, and then we end up with -5 squared. And we already know that f of 0 is -100, just like the graph shows. I'm going to let this a tag along with us as we go. We got to follow the order of operations. So -5 squared is 25. 4 is just tagging along as well, equals -100. I'm going to move the a to the back because that's where we're used to having the variables. So let's go ahead and get it where we're accustomed to doing it. This is equal to 100a when it's supposed to equal -100. Well, this is an easy fix. We divide by -100, excuse me, divided by +100 is -1. So all we need to do is now put this a value back in front of our equation that we found at the beginning, and that will regulate our formula to match. So this is -x plus 4 times x minus 5 squared. And again, I'm going to be very frustrated with you if you do not graph these and see if it matches the graph that we're looking at. And if you're given multiple choice, there's nothing that can stop you from just plugging in the equation, seeing which one matches. Let's verify what we know first of all. This graph is leaving through the bottom. So we should have known that that was going to be negative coming into the thing. We also know it leaves from the bottom and comes in from the top, which makes it odd. And that's exactly what we have. We have a power of 1 and a power of 2. It's a total of 3. So we do have an odd equation, odd degree, which is leaving through the bottom. All right, we're moving along on this one as well. I think we're all getting pretty good at writing the equation. It's just this new a thing that I'm throwing into you that might be a little confusing to you. But we recognize that it is crossing at -6, which comes from the factor x plus 6. And we also recognize that it's crossing at -2, which comes from the factor x plus 2. But do we see what's happening at that x plus 2 factor? Hopefully we recognize that bounce behavior. So this is going to be an even degree, even multiplicity. In this case, it is 2. All right, now our would be 18. Let's see what our equation actually becomes when we plug in 0. Let's see what our equation actually becomes. And then we may have to, again, scale it back to where it fits. So this is going to be 0 plus 6 times 0 plus 2 squared. According to our graph, the y-intercept is 18. Let's see if our equation agrees. So this is 6. This is 2 squared. And then the a value is just going to fix it to make it where it does fit. If it's not 18, we will make it 18. So this is 6 times 2 squared, which is 4. So you can see, those of you that are pretty good with your factors, that it is not going to equal 18, but that's okay, because our formula is going to fix it for us. So this ends up being 24a. Our y-intercept with our equation is actually 24. So we need to scale it back a little bit, and that's very easy. We divide by 24. And this is going to scale it back for us to where our equation will not only hit the x-intercepts like we want to see, but it's also going to cross the y-intercept where we want to see it. So both of these values have a factor of at least 2. 2 would move the 18 down to a 9. This would move it down to a 12. So I didn't factor enough, because we can now, I should have factored a 6. I didn't. That's okay. We'll get to it. Now I can factor a 3. A 3 from 9 is 3, and a 3 from 12 is 4. So our scale factor is 3/4. So all we have to do to fix this is take our original equation up here at the top, and in order to scale it back to what it's supposed to be, we replace our a value with 3/4. Now this equation works. All right, so we're going to end with a little fun one here. It's W-shaped. This is the sign of a quartic function, fourth power. So let's write our function. We have crossings at 1, which comes from x minus 1. We have another crossing at 5, which comes from x minus 5. Both of these, I said crossing, but really they're bounces. So both of these are multiplicities, and both of these are multiplicities of 2. Now, I should be more specific and say multiplicities of even numbers, but we want to make this the simplest form. And notice that it even says any form. So any form, might as well pick the smallest one, right? So we're going to leave a space for our scale factor just in case our y-intercept isn't where it's supposed to be. I want everybody to understand that the equation that we wrote in blue here will touch here, will bounce here. It will do what we see here, but it could have been where it's flat and it crosses low like this. Or it could even be higher and it touches at these spots. So let's see if our equation crosses at the y-intercept the way it's supposed to be. By the way, a little shortcut if you're interested. If you were to graph this thing and then just simply look at the table and see what y value comes out, what y value comes out instead of 18, all you got to do is divide 18 by that number and you have the scale factor. So that would be a really quick way of doing this as well. But let's just do it this tried and true way. So I'm plugging in 0 to see what my y-intercept is. Remember, anytime you want a y-intercept, just plug dx in as 0. According to our graph, our y-intercept is supposed to be 30. Let's see if ours actually comes out to be 30. This ends up being -1 squared. This ends up being -5 squared. If you don't use parentheses, you're going to have an issue. Remember, parentheses are very important. This is -1 times -1, which is 1. This is -5 times -5, which is positive 25. I'm going to move the a to the back just because we like to have variables in the back. So you can see my y-intercept for my equation is only 25, where it should be 30. So all I need to do is to fix this is divide both sides by 25. And my scale factor ends up being 30 divided by 25, which simplifies to 6/5. So once I've done that, I just go back to that equation I had, and in place of my scale factor A, I'm going to replace 6/5. So in this case, we needed to stretch it a little bit. A lot of the other ones we've had to compress them, or excuse me, I said that the other way around. This one is a stretch though. So our equation would be this. The 5 and the 1 could be reversed. All that matters is all the information is there. All the information is there, so there is our equation. You guys have a few examples of your own on Delta Math. Good luck.